All right, so we're on problem 23 of the final exam practice, and we are given a vector b. We know the components of it, and we want to find a second vector a such that the scalar projection of a onto b is equal to 2. And so essentially what this means is we want this vector a to kind of have length 2 in the direction of b. Okay, so whatever that means, right? But either way, we know that the scalar projection of a onto b is just equal to a dot b divided by the length of b. So this is our kind of length of a in the direction b, right? This is what the scalar projection tells us. So either way, we could compute this dot product, writing out coordinates of a, but nobody wants to do that. So like I said, we're going to think of this vector a as just going exactly in the direction b, so it's just some scalar times the vector b. So let's just say I'm going to make a equal to some scalar times the vector b. So it's exactly just pointing in the direction b, and it just has some length, and I want to figure out what that length is. You might already see that that length should be 2, and we'll find that out again. So either way, I know that I want the scalar projection to be equal to 2. So this a is alpha b now. This is dotted with b and then divided by the length of b. And so for us, this is equal to alpha times the length of b squared divided by the length of b. Okay, and so now I have 2 factors in the numerator, 1 in the denominator, and so I see that alpha times the length of b, it needs to be equal to 2. And so what that means is that alpha better be equal to 2 over the length of b. So what this is telling me is I need to make a equal to some unit vector in the direction of b, so b divided by its length, and then multiply that by 2, and that will give me a vector with length 2 in the direction b. So this works as a vector that satisfies this property, and so if we want the coordinates for this vector, we're just going to have to do 6 over the length of b is going to be square root of 9 plus 1, so this would be square root of 10, and then will be 0, and then minus 2 times square root of 10. And so these would be the components of this vector a.